This method is used to replace damaged BGA pads with new dry film, adhesive-backed pads. The new pads are bonded to the circuit board surface using a specially designed bonding system or bonding station. The minimum skill level needed to complete this procedure reliably is advanced. The conformance level reached when this procedure is completed properly is high. See the web page for a list of the tools and materials required to complete this procedure. The procedure follows. Step 1. Clean the area. Step 2. Remove the defective pad and a short length of the connecting circuit. Step 3. Use a knife and scrape off any epoxy residue, contamination, or burned material from the board surface. Step 4. Scrape off any solder mask or coating from the connecting circuit. Step 5. Clean the area. Step 6. Apply a small amount of liquid flux to the connection area on the board surface and tin with solder. Clean the area. The length of the overlap solder connection should be a minimum of 2 times the circuit width. Note: when desirable, the connecting circuit of the new BGA pad may be inserted into the connecting via hole of the original BGA pad. Remove any solder mask from the connecting via hole and prepare as needed. Step 7. The area for the new pad on the board surface must be smooth and flat. If internal fibers of the board are exposed or if there are deep scratches on the surface, they should be repaired. Refer to the appropriate procedure. Note: the height of the replaced BGA pad can be critical, especially for eutectic bolt parts. Remove any solder mask between the BGA pad and the connecting circuit or via hole on the board surface to maintain a low profile. When necessary, mill slightly into the board surface to ensure that the connecting circuit height does not interfere with the replaced BGA component. Step 8. Select a replacement BGA pad that most closely matches the surface mount pad to be replaced. If a special size or shape is needed, they can be custom fabricated. Note: new BGA pads are fabricated from copper foil. The foil is plated on the top side with solder, and an adhesive bonding film is applied to the bottom side. Step 9. Before trimming out the new pad, carefully scrape off the adhesive bonding film from the solder joint connection area on the back of the new pad. Caution: scrape off the epoxy backing only from the joint connection area. When handling the replacement pad, avoid touching the epoxy backing with your fingers or other materials that may contaminate the surface and reduce the bond strength. Step 10. Cut out and trim the new pad. Cut out from the plated side. Cut the length to provide the maximum allowable circuit overlap for soldering. Minimum 2 times the circuit width. Step 11. Place a piece of high-temperature tape over the top surface of the new pad. Place the new pad into position on the circuit board surface using the tape to help in alignment. Step 12. Select a bonding tip with a shape to match the shape of the new pad. See the bonding tip chart in the replacement parts section of the manual provided with the repair system or repair kit. Note: the tip used for bonding should be as small as possible but should completely cover the entire surface of the new pad. Step 13. Position the circuit board so that it is flat and stable. Gently place the hot bonding tip onto the tape covering the new pad. Apply pressure as recommended in the manual of the repair system or repair kit for 5 seconds to tack the new pad in place. Carefully peel off the tape. Caution: excessive bonding pressure may cause measeling in the circuit board surface or may cause the new pad to slide out of position. Step 14. Gently place the bonding tip directly onto the new pad. Apply pressure as recommended in the manual of the repair system or repair kit for an additional 30 seconds to fully bond the pad. After the bonding cycle, remove the tape used for alignment. The new pad is fully cured. Carefully clean the area and inspect the new pad for proper alignment. Step 15. If the new pad has a connecting circuit, apply a small amount of liquid flux to the lap solder joint connection area and solder the circuit from the new pad to the circuit on the circuit board surface. Use minimal flux and solder to ensure a reliable connection. Tape may be placed over the top of the new pad to prevent excess solder overflow. Step 16. To prevent solder from flowing from the new BGA pad into the connecting via or circuit, scrape solder off a small length of the connecting circuit exposing the copper. This step creates a break preventing solder starvation at the new BGA pad location. Step 17. Mix epoxy and coat the lap solder joint connection and exposed copper area. Cure the epoxy per procedure 2.7 epoxy mixing and handling. Use the maximum recommended heat cycle to ensure the highest strength bond. BGA pads are routinely subjected to one or more reflow cycles. Note: additional epoxy can be applied around the perimeter of the new pad to provide additional bond strength. Caution: some components may be sensitive to high temperatures. Step 18. Apply surface coating to match prior coating as required. Evaluation. Step 1. Visual examination. Step 2. Measurement of new pad width and spacing. Step 3. Electrical continuity measurement.